Let's take a look at the kinetics of radioactive decay. For N particles becoming decay products, the rate is first order. It equals lambda times N. This translates to the logarithmic equation Nt over N0 equals minus lambda T, where N is the number of atoms at time T and N0 is the number of atoms at time 0. Lambda is the decay constant, and it's related to the half-life. It's equal to 0.693 divided by lambda. Here we see the half-life of iodine-131. As it decays, it is a hyperbola, never quite reaching 0. Strontium-90 has a half-life of 28.1 years. How much of a 1.2 gram sample would remain after 10 years? Again, log of Nt over N0 equals minus lambda T. Lambda would be 0.693 divided by 28.1 years, the half-life, or 0.0247 years to the minus 1. Solving for Nt, that equals N0 e to the minus lambda T, or 1.2 times e to the minus 0.247 times 10, or 0.94 grams. So in 10 years, we decrease from 1.2 grams to 0.94 grams. Radioactive dating. Walter Libby in 1950 realized that carbon-14 decays into nitrogen-14 and emission of an electron. The half-life is 5,720 years. Living organisms incorporate the ratio of carbon-14 and carbon-12. When the organism dies, the ratio changes. Clearly no more is taken in, and the 14 decays. So the 14 to 12 ratio is going to get smaller. The date can be found from decay kinetics. Look at the next problem. Tritium-3 has a half-life of 12.3 years. Let's estimate the age of a bottle of scotch that has a tritium content of 0.42 times that of water from which it is made. In this case, again, we use the same equation. Log of Nt over N0 equals minus lambda T. We use the half-life equation, solving for the rate constant lambda, 0.693 over the half-life, making the substitutions, 0.42 over 1 equals minus 0.693 over 12.3 years times T. Solving for T, it equals 15 years. It's an old bottle of scotch. Transmutation. These are bombardment reactions. Here an alpha particle bombards an aluminum 2713 nucleus and converts it to phosphorus 1530. The phosphorus 1530 decays into silicon 1430. This was the first reaction discovered by Irene Curie, Marie's daughter, and Frederick Joliot, her husband, in 1934. They produced this first artificial isotope. Here are some more nuclear transmutation reactions. In the first case, nitrogen reacts with an alpha particle to make oxygen 17, aluminum 27 again, making phosphorus 30, and nitrogen 14, making carbon 11. These are done with a cyclotron, which is outlined in the diagram to the left. It has an alternating magnetic field that accelerates a particle round and round and round until it gets enough energy to impinge upon the target. Nowadays, linear accelerators are used. The photograph here shows a linear accelerator found at the University of California in Berkeley.